All right, so the practice test, which thing?
It's just a general question.
Oh.
When we're graphing inequality, if there's no greater than or less than sign, there's no shading, right?
Then it's not an inequality. So number 2 says graph and give interval notation for inequalities.
Yeah.
So which one of the problems out of number 2 are inequalities?
I'm assuming G and F?
Yeah, don't assume anything. They have an unequal sign, right? Some inequality. Greater than, less than, less than, equal to. So F and G are the only ones you need to do those for.
So then for A through
F, that doesn't apply because they're not inequalities. They are equalities.
So we're just solving for X?
Just solve it like normal. Yep.
Okay.
Yep. So graph and give interval notation for the inequalities, so for F and for G.
Okay.
One, number 2. Is that cool? Yes.
2.6.
Bless.
Yeah. 2.6, number 25.
Oh, there. 3.6, number who?
25.
24?
25. 25.
25.
Sorry.
Oh, so we talked about septal notation. Do not worry. Do not do it unless you already did it, which is fine. We talked about it. This is number 25 in section 2.6. This one says y less than 6. This one here, right? And it wants you to graph it. Number 25, section 2.6. It says to graph it and interval notation it. I think, right? Yeah. So, how do I graph this?
Oh, is it the same? Oh, I thought
I just have one letter. You don't have to worry about like doing this for the y-axis.
Okay, then I'm good.
If it's T, if it's M, if it's A, I call this the
Okay.
Y number
Yeah,
line,
I
T
thought
number
you had to
line.
do I'm good.
Is everybody cool with this problem?
Yeah.
Is anybody not cool with this one? Just to, if it's 6, well, we'll go on to 6. Parentheses. Facing which way? So we're going to shade down. Please don't do this. We talked about that, right? Didn't we? If that's negative infinity, what the hell's that? This thing right here. I went beyond infinity, right? That's not buzz stuff here. Yes. All right. I skipped somebody. Where am I thinking? Oh, yeah. Wait.
2.6, 20, if it adds 0, it's like the same thing.
Which one, sir?
20.
Oh, yeah. 20 got a lot of people. Let me ask you this. 8 and 3, how are they related? Which one's bigger? 8. What if I put 3 first? Does the sign stay the same? No, hell no. So if my variable is on the wrong side, so like number 20, same section, 0 less, is it less than equal? Yeah. How do I turn that around so the variable's on the correct side? If 0 is less than or equal to t, t must be bigger than or equal to 0. Now you're going to shade it the correct way. Everybody was doing this, 0 and shading down there. 0 is not less than negative 1. Right? This can't be where the shading is. No. The variable is on the incorrect side, so just flip the whole thing. Mirror image the whole thing. Is that all right? Do you guys see that?
So you still shading right?
You definitely shade in that direction. Yeah, if the variable is on this side, you can see which way to shade easier. Yeah.
Read 1, number 10.
Oh, okay. Let's see. Use the example. Use the information in example 2. So you're going to go back to example 2. And they give you this little pie chart, right?
Oh, I was not sure whether.
Oh,
What page is the example?
it's on page 161. Is that cool? So they use the information example 2 to answer those following exercises. Yeah. Otherwise, you're right. You can't do it. Okay. Yes.
32, number 30.
Oh, okay. So here's a good example of being smart about what x is to pick. So when you go to graph a function, how do you know what x is to pick? Well, you can use any you want to. But on this problem, and any of these problems, I want to be smart. What was it? 30? Is that the one?
Yeah.
This is section 3.2. So if I go to make an XY table, do you want to use 3 for x? Is that an easy, what do you get when you put a 3 in? You get 3/4. It's not the easiest thing in the world to graph, right? So what numbers make sense to plug in for x?
0,
0 makes sense.
1,
I agree with that. 1 doesn't make too much sense. Sorry, buddy. Because what are you going to do to the x?
Oh, 4.
You're going to divide it by 4. So what about things that are divisible by 4? Right, so 0 is always a good idea. What do you get when you plug a 0 in? Y equals 1/4 times 0? 0. What do you get when you put a 4 in? What's 1/4 of 4?
1,
Bless you.
What's another good thing to use?
Bless you.
What about going the other way?
-4,
What's 1/4 of -4? -1. Yeah, now you got some points to plot. You can pick which things to put in for x because you're going to connect it and pick up everything else anyway. That's why it doesn't matter which ones you pick. So if there was a 1/3, I'm going to put multiples of 3. If there's a 2/5, I'm going to put multiples of 5 so that it divides evenly. Get nice whole numbers to the graph. Does that make sense? I don't want to have to estimate where 0.25 is. I want nice whole numbers to graph. Is that cool? Yeah.
3-1, number 60.
Oh no, did I give you that one? All right. Let's skip the graphic calculator problems for right now. We're going to come back and focus on graphic calculator. I wanted to first get us to graph stuff by hand, and then we're going to come in afterwards with the graphic calculator.
You can do these calculators on the test?
Yes, but as always, you're going to show me some work, right? Oh shit. So that means you don't write 17% of 20, and then all of a sudden the answer is here. No, you got to show me what the hell, how do you go from here, what's the equation look like, right? And then you can plug it in the calculator. So there's a balance between showing me what leads you to what you put in the calculator, then you put it in there. You write the answer, but you got to show me something. Okay, I like it. Yes?
Can you do 60 on section 26?
2.6. So let's see, 60. Oh, okay. Bye. So this is the one that's got a very focused issue. Negative 16x less than negative 64, I think? Yeah. One step, but it's really making a point out of the one difference between solving inequalities and equalities. How do we get the x by itself? Divided by negative 16. Which means what?
Science law.
Good. And here I get 4. Okay. So you got to remember that sign has to flip, and we talked about why. Why? Because
we have negative.
that's how numbers work. Right? When you multiply by negative, you change the side of 0 you're on, so you change who's bigger, who's smaller.
Just another general question.
Real quick, is everybody cool with that? I think, did it say to graph it? Is that cool, Karen?
Just a question. If that was a positive 64, would the caret still?
Yes, completely. So watch this. The real difference, so let's see. If it would have been this. All right. So this is something funny in the next room. And divided by negative 16, cool. What would I have gotten now? That would have still flipped. Why? Because I divided by a negative. But now this, of course, would be negative. What about if it was this? What do you divide by now? You divide by 16. So what happens to the sign? Stays the same, because you did not divide by a negative. There's a negative in there, I don't give a shit. I divided by 16. Everybody stays in the same place of 0. They don't switch. I didn't divide by a negative. I didn't multiply by a negative. The sign will not flip. So for example, like, which one of these is bigger? 8. If I divide by 4, now I get 2 and negative 1/2. Which one's bigger? 2 is still bigger. See? I didn't change the side of 0 it's on, so I didn't change who's bigger. If I had 8 greater than and I divide by negative 2, what happens? What's negative 2 divided by negative 2? And what's 8 divided by negative 2? Which one's bigger now?
1.
See, it flipped. Because I divided by a negative. Not because there's a negative in there. Right? I like it. Okay. Was I in the middle of something with somebody, or Cameron? You were about to say something.
Yeah. So let's say you're distributing to something in parentheses. If it's like 2 minus, and then in parentheses it's just a 2, you distribute the negative first and then the 2?
If it's just like this?
Yeah.
No, wait a minute. You mean if it was 2 minus 2 times something, right?
Yeah.
Yeah. Like that?
Negative 2 minus 2, right?
So watch. You ready? The easiest way to do this is to take the negative 2 through. Because really, what is 2 minus? It's 2 plus negative 2. See, it is a negative 2 I'm bringing through. If you brought the 2 through, what would suck about that is the negative would have to sit outside of this. You still need parentheses. That gets weird. So what you guys have got to realize, a negative sign is a minus, and a minus is a negative sign. We just don't write positive signs all the time. Like here, if I put a 7, do I need a positive sign? All right, what if I combine it with a 4? Oh shit, the positive sign has to show up now. That's the idea, right? So I don't write a positive, we just know it's positive if it is negative.
Well, because like on the practice test,
Yes.
G, it's 6 minus, and then
Oh yeah, oh shit. Well, all right, G. Oh gee. It's got a little bit more going on. This is the problem. Some of you guys might look at it and go, I don't know if I'm going to do that. It's like I ate some algebra and got sick and threw it. Blah, and there's some algebra for you. What are the last 2 things I'm going to worry about? The 6 minus?
Yeah.
And the plus 2, because it's all 6 minus something. Oh shit, I better figure out what that something is. Now inside there, what do I do first? So this is going to come for the ride. That's going to come for the ride. Inside here, I get 3 plus negative 2. Get out of there. And then you just keep going inside. Exponents, division, multiplication. Then you add those things, right? Good old PEMDAS. Once you finally figure out what that number is, you can subtract it from 6. And then add it to 2.
okay.
Alright, some of you guys look like you're in pain. I'm sorry. Some of you guys might actually be in pain, so I'm sorry. But I don't know if I think I'm causing some of you guys some math pain. But is this all right? I mean, what would the next step be? Yeah, what is that?
Negative
Negative 8. 2 times 2 times 2. 2 times 4 to 2 times 2, 8. And then now I divide by 4. I don't have any 28 in this here, right? The 4's on the bottom, the 7's on the top. They don't make 28. I do that piece as it comes. So then the next thing I would do is divide. Yeah, division, multiplication, do it as it comes. That's why I really, really hate when people write this like this. That's so evil. Because remember, it could have been Pedmasov, but then we all sound drunk. I'd rather be drunk than just sound drunk. Yes?
Are you just dividing the one number, the -8?
Yeah, that's the only thing that's being divided by something. That is the only thing that's being divided by something, and 4 is the only thing dividing into something. How do I rewrite this inside? 3 plus -8 over 4 times 7. See, the 7 is not underneath there. It doesn't become 28 somehow magically. That is another way to write this, isn't it? How do I rewrite -8 divided by 4? -8 over 4. Then what's it say? Multiply by 7. Okay. That's why I don't do multiplication for division always. That's craziness. You can see why people think that, because PEMDAS. That's why I write it like this. Because you definitely do these at the same time. Whichever one's first. Multiplication, division, and then whichever one's first, addition and subtraction. You went far enough with that. You guys can finish that out. Yes.
3, 1, number 60. No, sorry, number 40. Sorry.
40? Oh, okay. So, all right. So this is beautiful. This is the kind of question I expect. This is all about picking the right scale. Your scale doesn't always have to be 1, 2, 3, 4, 5. Thank God it doesn't. Because if I have to plot the point 600 something, well, I'm trying to pick 4, 5, so I just knock the wall down, keep going. So they want you to plot, let's see, let's look at one of these points. They want you to plot 738, -89. Let's keep going. Right, this is the one? Yeah. -49 and -6. -165 and 53. Now they tell to use a grid that's got 10 tick marks. They say, what does it say? 10 squares wide and 10 squares high. I don't know what they mean. I'm sorry. No, I can't possibly have this be 1, 2, 3. Because I have to get how far for this point? How far do I have to get over for this point? 738. Is everybody, this is x, y, just like plotting the point 1, 3. 1, 3. But I can't use that scale. You can if you want to make a thing that huge. I don't want to. So, for example, you could do 10, 20, 30. Is everybody cool with that? I guess.
Yeah.
We all have seen this before, like the income of some company is 500, 1,000, 1,500, 2,000. They don't make the scale ones. Not everything can be represented by one step. Your steps, now is 10, 20, 30 going to be good?
No.
So what do I use then? Maybe, yeah, maybe 100. 50 might work, but let's see, 100, 200, 300, 400, 500, 600, 700, 800. Can I find 738?
Yeah.
Yeah, approximately. You don't have to make it perfect, right? We're doing this by hand, so you can't have to be perfect. And then what about this scale? Doesn't have to be hundreds, thank God. As long as, now what's it got to be back here on the x-axis? What's that got to be?
100.
Negative 100. Negative 200. So forth. Now this could be by 20s, it could be by 1s, it could be, as long as it's consistent on each axis. And we've seen things like this before. You've seen stuff where they're like, well, in 2010, there was 30 billion. And in 2015, there was 60 billion. You know. So this scale is by 30s. Right? So you've seen things where the scales are different. So now I can find 738, negative 89. So what scale do you think I want to use here?
Tens.
Yeah, 10s would be nice. 10, negative 10, negative 20, negative 30, negative 40, negative 50, 70, 80, 90. So 738, negative 89 would be very roughly right there. Because, you know, grid graph paper will certainly help. You can Google graph paper images and print it out. Or go buy some graph paper. You got to buy the damn paper in the first place anyway to print that out. Yes? So it's a good investment in graph paper. On the test, I give you a little graph. You just have to pick your scale correctly. Cool. Does that make sense? Yeah.
Are you done with that one?
Yeah.
On 3,
I think I am. Yes, all right.
on 3, 115, kind of
3-1 number
15.
50?
15.
15. Americans are recycling about 34.1% of all glass that is in the waste stream. That sounds great. How much glass did Americans recycle in 2012? See exercise 13.
Because it gave us total waste, which was 250.9 billion tons.
250.9 million tons, yeah?
And 4.8% of that waste was recycled glass.
Ah,
But then it's saying that only 30 whatever was.
well,
38% was recycled.
so 4.8% is
The total recycled.
glass. I like it. So 4.8% of the total stuff is glass. Number 13 says they generated 250.9 million tons. So on number 13, they ask you how much of that was glass. Right? Now I know I didn't assign 13, but unfortunately I assigned a problem that makes you reference something. So you basically have to do number 13. 13, you figure out how much is glass. And then 15 says 34.1% of that was where'd it go? Recycled.
So I need to figure out what 4.8% of 250.9 million is.
Beautiful. And that's how much glass. And then you got to figure out 34.1% of that
Okay.
to answer 15. I like it.
Okay.
So it's a two-step process.
Okay.
Yes. Oh, shit. Because, of course, that's what happens in real life. Right? You say 18% of people under the age of 20 voted. 7% of those people actually read about what was being voted on. So you have to do multiple percentages to get that tiny subgroup.
So then I'm assuming number 10 is the same way with the education tax.
So number 10 is that one that says refer to example 2?
Yeah.
Yeah, so 10, let's see, what was the average education tax benefit? And they take you back to example 2. So that's still back on page 161. 23,500,000 full-time equivalent students. And where they got that? Yep. What was the average education tax benefit received? And there's the education tax benefit is 8%.
Yeah.
There you go. So if you do 8% of the aid,
Yeah.
and then you have to do
Divided by the amount of students that are
beautiful
receiving it?
to figure out the average amount.
Okay.
Yes. Ooh, two-step problems. I love them. Really, the point of 3.1 is here's graphs you see all the time. How well are you able to read them? Because you see pie charts out there in the universe. However you get your news. Or accidentally you see it in the newspaper somebody next to you has. They still make those. I still read those. Practice test. It's wide open, yeah.
One F.
Whoa, sorry.
Can you do
No,
one,
come to you.
1K real quick? I'm just confused, like, can I combine those like terms, 3x or negative 3x squared and negative 4x squared, even though negative 3x is in parentheses?
See, that's the problem. It's stuck. How do you unstick it? Well, you distribute. That's why distribution is almost always the first step in solving equations, so then we're able to move the parts around.
Okay.
You said it perfectly. It's stuck, so I can't move it to be with the other x squares.
Okay.
You got to distribute that too. And I haven't addressed this specifically yet, but I've seen this enough now that I'm troubled. So what is 4x plus 7x? 11x. If I put another number here in the middle, like minus 5y, and I said simplify this, I'm about to make a really big mistake. I'm about to make a really big mistake. See way too many people doing this. What? You do the same thing to both sides. Is there another side to this? There's no equal sign. There's no side. There's no less than or equal to sign. Right? There's no sides. It's just 4x and 7x. It's still 11x. If you do this, now watch, that's the correct answer. If you do this, minus 4x, I actually just subtracted 8x. Minus 4x, minus another 4x, I just subtracted 8x out of nowhere. Right? Bam! And then what do I get here? 7x minus 4x? Right. Now notice how many x is too, that's the wrong answer. 3x is how many x is too few. It's supposed to be 11. I only got 3. How many x's short am I in this? 8. See, that's the 8 that you took away. You took 8x away from this poor dude. Right? It's sort of like me saying, what's 4 plus 6 plus 5? And you go, well, let me take 4 away. That doesn't make any damn sense. It's all being added. There's no two sides to do stuff to. That's if you need to move something from one side to the other. That's when you do that kind of stuff. Not all of you are doing this, but enough of this I'm seeing it's gotten me a little worried. Yeah.
H, 1H.
Oh yeah, that's a yummy problem. So this is why people think division is last. Real quick, if I write this, how could I write that a different way? It wouldn't be this. That's not right. Those are not the same thing. What's missing? Yeah, the top, bottom. I don't need it in this format because I can see the top and the bottom, but officially these are there. But then everybody thinks division is last because these kind of problems division is last. It's only last because everything else is in frickin' parentheses. So everything else is first artificially, right? This problem is like that. So you have a top problem. Pick it up, Jeff. There you go, buddy. Oops. Divided by. So you got a top problem and a bottom problem, right? So this is number 1H. So you work the top problem out. While you work the bottom problem out, the minute the top and the bottom are both a number, you can then try to reduce it. Right? So on the top, what do you have to do first? Yeah, you can do in here. Yep, in here you do the exponents. And then you add 1. Out here you do the exponent, and then you can divide. Yeah. So the top is a problem, the bottom is a problem, and the last thing you do is, it's a fraction now. You see if you can reduce it. It'll be number over number. So what would the top, if I do this, what's 3 cubed? 27. What's 2 cubed?
9. I mean 8.
8 plus 1? 9. There you go. 9 caught up to you. Down on the bottom, what would you do first?
Negative 21.
Yeah. So you get 4 minus 42. So a lot of you guys, you see a problem like this and you start doing stuff around the edges, but what happens is you don't put them back together correctly. So it's not really making it go quicker unless your goal is to make a bad score. Then you get there really quick. You want to rewrite stuff so you don't miss where things are. Math is hard enough already. Don't trip yourself up by putting things out of order.
Right there, you just work the top and the bottom.
Yeah. So up top, what would you do next?
27.
Yeah, 27 divided by 9 is 3. You can add those. On the bottom, 42 divided by 7 is 6. So then you subtract those, right? You get a number over a number, it reduces. Then you're done. If there are fractions in a problem, I want to see a fraction answer. I don't want to see decimals. Because that means the old calculator came in there and did it.
I was gonna ask you what
Yeah.
F.
One F. Oh, yeah. So any questions on this one, though?
How'd you get 27?
Oh, 3 cubed. So 3 times 3 times 3.
Oh, okay.
Yeah. Is that cool?
Yeah.
Yeah? No. So 3 cubed. Are you cool with the fact that I'm going to do 3 cubed?
Yeah.
Okay. Because that would definitely be before division.
Okay.
Right? Exponents before division. So 3 cubed means 3 times 3 times 3. 9 times 3. 27.
Oh, okay.
Yeah.
Alright.
So really, the interesting, real quick side note about exponents, and come back to 1F. Exponents are interesting. What? Let me see if I can trip you guys up. This is not exponents. What's x plus x plus x plus x? 4x. So coefficients are repeated addition. If I write a 4 in front, that means 4 of these adding. It's shorthand, right? But if I do this, so my little story is, one guy on one side of the earth did this, and he told everybody, and everybody's like, oh shit, thank God. I was going to write 80 x's. Now I can just write 80x. Thank God. This guy's like, oh shit. I wanted to put the 4 out front for this, and this dude already did that shit. Damn it. So where else can I put the 4? Maybe I can put it underneath. That looks like division. Up here. That just looks weird. Let me put the 4 here. I mean, it really was. It's not like aliens came and said, do this or we will kill you. We're like, all right, we'll do that. No, we chose to put that there. There are 4 x's here. But they're not adding, they are multiplying. That's what putting the 4 there means, right? I mean, that's where it came from. So are we cool with that? Later, when we talk about properties of exponents, they all come from this definition. What was I in the middle of? I'm sorry. Oh, yeah. Sorry.
No problem.
Did you have a question about that, or?
Yeah, hold on.
Yeah, go ahead.
So if you were to add x to the 4th power plus x to the 4th power, it would
I love
just be
it.
x, a 2x to the 4th power?
Beautiful.
Okay.
When people do this kind of thing, x to the 4th plus x to the 4th is 2x to the 8th. I'm like, I don't even see 1x to the 8th here. How the hell did you get 2 of those suckers? Right? One of these plus one of these is 2 of these. So coefficients keep track of what I'm adding.
But if it's multiplied, it would be 2x. Or
Yeah, x to the 4th times x to the 4th.
16th.
Careful.
Or
How many 4s in a row? How many x's in a row here? 4 of them.
4.
How many 4s? How many x's here? 4 more. So how many x's total now? Yeah.
Oh, so you add.
It's really the same thing as this. What's 4x plus 4x? 8x. 4x is adding plus 4x is adding is 8x. 4x is multiplying times another 4x is multiplying is a total of 8x is multiplying. And then I really freak people out and I say there is no 4 in that statement anywhere. There's no 4 here anywhere. And they go, you forgot your meds or something. It's a freaking 4. No, what does that mean? There are 4 x's. There is no 4 here anywhere. There are 4 x's in a row. I write it like this, shorthand. Another 4 x's in a row attached. That's 8 x's in a row now.
And division's the same.
Yeah, divisions, but we're getting a little ahead. That'll be properties of powers later. Division, you lose stuff. You subtract. Yeah. Because you're undoing the multiplication. You're breaking the chains. All right, bringing it back to what we're worried about right now. Is that thing still going? Thank God. Yes. Oh, wait. Let me finally answer your question. You're so patient. You just sit there like, he's going to take somebody else again. I'll just sit here. All right, 1F. All right, what do you do first in this equation? Where do absolute values show up in order operations? What do they look like? They're parentheses. They're the same place. They just have an extra, parentheses just group things. Absolute values group things, and then they say make the answer positive. So I do inside first. What do I get inside? Negative 3. I like it. Now what is the absolute value of negative 3? So that is 3, and there is a negative sign on it. So absolute value is always positive. Therefore, negative absolute value is negative. Nothing major there. Sometimes I get students say, you said it was always positive. That's negative. Well, there's a negative there. What do you want it to do? Times 6 divided by 9 minus 1. What's the next thing I do?
Times negative 18.
Good. Negative 18 divided by 9 minus 1. Negative 2 minus 1. Yeah. So you from the beginning you knew that that minus 1 was last. The subtraction is way at the end of PEMDAS. All right, let me see.
2E.
Oh yeah, all right. 2E is one of our favorites. Oh, cool. 2E is the one that's overloaded with fractions. Now there are other ways to do this. But the reason I do it specifically the way I showed you is because it actually is the same way we have to do it later when the bottoms become variable expressions. Oh, shit. Plus it just makes it, to me, it makes it a little easier to follow the logic. So what did I say to do? These are all fractions, so what are they almost always required? They're being subtracted and stuff. Yeah. LCD. What's the LCD going to be? 30. These numbers are pretty simple to look at. You can see it's going to be 30, hopefully. So then you make everybody have a 30 on the bottom. What do you do to this guy? Or a little mutant 3. Yeah. So now I've got 20 x over 30 minus 8x over 30 equals 21 over 30. It's an equation, so what am I allowed to do? That I would love to do. Multiply by 30, because everything's being divided by 30. If I multiply by it, all the over 30s go away. Sounds like Logan's Run. All the people over 30. Just kill them. Bam, 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 bam. So you get 20x minus 8x equals 21. Why was I allowed to kill those fractions? Because it's an equation. There's two sides that will balance each other out. I can't kill an innocent fraction sitting there. But these guys, they're in an equation, kill them. And now it's easy. Now it's a couple steps away, right? Right? 20x minus 8x. Yeah, you divide by 12, and you better not stop there. You reduce. Yeah, they're both divisible by 3. So 7 over 4. Okay. Here, let me go ahead and give you guys, I'll give you guys the answer key. In case some of you did this already. You can check and make sure I got all the right answers. I'm averaging about a 97 on my answer keys. Pretty good. I'm human, there might be a typo or mistake somewhere.
Can you do that one more?
Of course, yeah.
3D?
Give me 1 second. Or several seconds. I'm just gonna make you sit there and be like, oh. There you go. That's one more back. Next one. I'm sorry, man. Which one?
3D.
3B? Okay. Well, if you want to now, you can look at it on the key. I'm thinking to myself, I already did that problem. So 3B is all about substitution, putting the value of Z and the value of A in. So is that cool? Let me know if that's not cool. Yes.
Okay, so 2D, since you're multiplying 27 by 5, you're not doing anything to 8 over 35.
Yeah. True. So the way I decided to do that problem, since 7 becomes 35 so easy, instead of cross multiplying in these big ugly numbers, if I make the bottoms the same, just like the problem we just did, so multiply by 5, so I get 10 over 35, and then multiply by 35. Now, if you cross multiply, you will eventually get to the same answer I did if you reduce correctly. But you make all your numbers way big, right? There's nothing wrong with that approach. It's just your numbers become larger than they have to. I decided to just use a general idea of if I make all the denominators the same, I can kill them. Is it?
Too much movie, it's irony.
That's you find out later. That's when the teacher had a few too many last night and they needed a day off. Yes?
That's normally the way I like to do your fractions, just multiplying the denominator. But I've noticed sometimes do like yesterday, for example, we went over a question on the homework, and the way I did it was I multiplied by the denominator to build the fraction. You did something else. We both got the same answer, except
All right.
Mine was a little bit longer than yours.
So, like right here, would you just multiply both sides by 35 immediately?
No.
Or no? I don't know what to tell you then. You have to show
I'm
me.
not gonna try to find it.
Okay. You get to have a lesson and almost hear whatever the hell they're watching.
We can hear it, might as well watch it.
I know, man. Just have a window in this wall. I might have to go over there. All right, I'm gonna go with it. You gotta hang up.
You want the
Come on,
free soda?
piece it.
You want the free soda? Go hit the vending machine.
Oh, really?
Yeah.
Oh, man.
Can't tell everybody that. Gotta keep the teeth still down.
It's free, bro.
No, you got that way. You're trying to get a special, don't know the game.
Trying to get a soda?
Oh, you got an app. You said you got an app. You did.
By hitting I read one line and I quickly just fucking around and then it came on top of that and I kept thinking in short of community.
Yeah, I'm about to go get one.
Go get one by other, go on the bench and do this little thing.
No, you didn't, bro. Stop playing.
I got one that I gave it to
Bro, where were you? I got one niggas is really struggling.
Bro, I wasn't trying to walk home like 5 sodas. What do you mean? Oh, they had like a whole circle. What you talking about?
So,
I'll hear everything you said about me. That's good.
the 4/5 that it comes down to is because the X goes on the bottom, because
No.
because you got it down to 10, X equals 8.
Totally.
Divided by 2 on both sides gives it 5. Becomes a fraction, 4/5.
Okay.
All right? Why is the 5 go on the bottom?
All right.
Because of the X?
You ready? No. So you're cool all the steps until here, right?
Right.
All right. Now, if you divide by 2,
Yeah.
let's see. So divide by 2, nothing really wrong with that, but it doesn't really get x by itself. Why is x not by itself?
Because it's got a 5.
How do you get rid of the 5?
Divide.
Yeah.
Got it.
That's why. There's no guessing.
Got it.
Guys, calm down. So I like to give a problem like this, because I'm evil. Let's make it, yeah. And I have a lot of people just kind of do x is 2. Next. Yay. But this is why I ask you to show me work, because I'm trying to save you from yourself. Why is the x not by itself? That's the wrong answer. Why is the x not by itself?
18.
18. How do you get rid of the 18?
Divide.
Divide by 18. What is 9 divided by 18? That ain't 2.
3, 6.
It's 1/2.
1/2.
Yeah. Do you guys see what I mean? Your brain goes, oh, 9 and 18 are easy. This is 2.
Yeah.
But you got to stop your brain and say, brain ain't. That doesn't make any damn sense. Because then you're saying that 18 times 2 is 9. That's neat. If you say that x is 2, do you guys see that? Checking it will show you that you have it the wrong way.
Got it.
Yeah, it's a really common mistake. And I like to put exactly this kind of problem, especially because I just told you about it. So you will have this kind of problem on there, just be careful. That's why you want to show the algebra. It's not just because I want to make you do the work because I had to. Now it's my turn. No, it's because if I make you show your work, you will make less mistakes, period. It's also easier for me to grade, but it's a nice little side bonus. But you making less mistakes is a bonus for both of us. People that don't show the work for themselves are the ones that make these mistakes, where things just kind of float over to the other side. Yes? Yes?
Number 4, ABC.
Oh, so 4 is like a precursor to word problems, right? 4a says 5 less than 3 times a number added to 8. So what's 3 times a number? Yeah, for number 4a, what's 3 times a number? 3x. You could use n, you could use whatever. And what's 5 less than that? So 3x minus 5. And then it says that added to 8. I want to add this to 8. Yes. Now I didn't say simplify. If you simplify, I'm not going to take it off, but I didn't say simplify. You just stop here. Right? So 5 less than 3 times the number added to 8. I think I even did this on the answer key, right? Yes. Just to show that this is the first thing added to the second thing.
Can you explain how you reduce 1C?
Oh, so let's see. So I went, what goes into 6 and 15? 3. So divided by 3, divided by 3. What goes into 14 and 35?
7.
7 divided by 7 divided by 7. 2 times 2, 5 times 5. Yeah. So you can reduce up and down, you can reduce diagonally because it's still up and down. Right? One of them's got to be up, one of them's got to be down. I like it. Yes?
But you don't necessarily have to do that. You can multiply through the cost and stuff like that.
Yeah, you can make your numbers big and then reduce. Nothing wrong with that, but it's just easier to reduce first. Yeah. There's nothing wrong with multiplying and then reducing. Not a damn thing wrong with that.
So like, I got 0 for some reason. Oh wait, never mind. I don't know. Wait.
Oh, did you think more stuff cancels?
No, I put
Or did you flip one over or something?
no, I put well, it's like 2 over 5 times 2.
Yeah, remember when you multiply.
I got 3 and 7 for the numerator of 6 divided by 30.
Oh, because you wrote what goes into 6, not what's left.
No, yeah, I did that.
Yeah. So you write what's left. You reduce 6/15 to 2/5 because 3 goes into both. Yeah. Don't put next to it what goes in. Put next to it what it becomes. Yeah.
So for division, do you put what goes into it if you divide fractions?
Yeah, so I never write, like if I had 15 over,
Thank you.
over 42 times 6 over, well, let's see. Yeah, 7 over 9, right? What goes into both 15 and 9? 3. So then 9 divided by 3 is 3. 15 divided by 3 is 5.
Okay.
You
so
put the
do
result.
You do the same thing when you divide two
When you
fractions?
reduce a normal fraction.
Oh,
When you
when you
divide.